Hi everyone, welcome back to Tech-Bimba channel. In the previous video, I talked about blocking queue in Java. In the today's video, we will dive into lock interface. Before diving into lock interface, it is important to understand the limitations of synchronization in Java. Synchronization ensures the thread safety in Java. Synchronization is achieved using the synchronized keyword. This keyword can be used with the methods, or we can write a synchronized block. Within the synchronized method or a synchronized block, we can place the critical section of the code. Synchronized keyword ensures that at any one point of a time, only one thread can access or enter into that critical section of the code. In this example, we can see that there is a class within which we are having an access method which is a synchronized. Here we are printing the name of the thread and we are mentioning that it acquired the lock. Then there is a thread.sleep. We are passing the parameter as a 5000, which means the thread that entered the access method will be interrupted for a 5 seconds. Then we are printing the name of the thread and we are mentioning that it is releasing the lock. Within the main method, we are creating the instance of the class and this object is being shared between the thread 1 and a thread 2. We can see that thread 1 is calling obj.access, means it's calling this method. Thread 2 also calling the same method. This is how thread 1 and thread 2 are sharing the access method or this object. Okay, and then we are starting thread 1 and also we are starting thread 2. Let's say thread 1 got a CPU cycle. Since access method is a synchronized, so JVM checks whether the monitor lock on this object is free or not. In this case, it is free. So thread 1 acquired the monitor lock and it entered the access method. So since it's entered the access method, thread 1 will execute this method, because of which we can see this line in the console. Thread 1 acquired the lock. Then thread.sleep 5000 will be called, because of which thread 1 will be interrupted for 5 seconds. Now CPU is idle. To utilize the CPU cycle, let's say thread scheduler has given a chance to thread 2. Now thread 2 will come and it will try to execute the access method. But access method is a synchronized. So JVM checks whether the monitor lock on the OBJ is free or not. In this case, it is not free because it is acquired by thread 1. So because of which thread 2 will enter into the blocking state. Let's say after 5 seconds, thread 1 releases the monitor lock. After that, thread 2 will able to acquire the monitor lock on the OBJ and it will enter into the access method and it will execute this block of the code. This is how synchronized ensures that at any one point of a time, only one thread can access the critical section of the code. But if you note here, thread 2 has to wait for the object's monitor lock indefinitely. So this is the first disadvantage. There is no timeout. Let's say we have a requirement. Let's say we want our thread 2 to wait only for 2 seconds. If after waiting for 2 seconds, if the lock is not acquired, let's stop waiting that. So that functionality or a capability is not present within the synchronization or a synchronized in keyword in Java. The second one is no tryLock. Let's say we have a requirement where thread 2 can basically check whether the monitor lock is available or not. In case available, let's acquire it. If it is not available, let's do some other task. That kind of a capability is also not present in the synchronized keyword or a synchronization in Java. Third disadvantage is, let's say one thread is waiting for a monitor lock of particular object indefinitely. Let's say it's taking too much of a time and we want to interrupt it by calling the interrupt method. Even if you do that, so the thread that is waiting for a lock, right, it will continue to wait. It won't be interrupted or stopped. So this is the third disadvantage. Fourth disadvantage is no fairness. Let's say we are having a thread 1, thread 2, thread 3, thread 4. Let's say CPU cycle is allocated to thread 1 and these are the threads basically sharing the resource. Okay, let's say thread 1 got a CPU cycle and it entered into the print method. Since there is a thread.sleep, Okay, thread 1 entered into the timed waiting state. Now CPU cycle is given to thread 2, and thread 2 will come here, and since it is a synchronized method, thread 2 will be entered into the blocking state because thread 1 still have the lock for this object. So after that thread 3 will come and it will also enter into the block state. After that thread 4 will come and it will also enter into the block state. Let's say after 2 seconds thread 1 releases the lock. Now JVM will not respect the order in which order threads are basically waiting for the lock or a resource. It might give a object's monitor lock to the 4, then to the 3, and then to the 2. There is no fairness is maintained by the JVM. So this is the fourth disadvantage. Because of this no fairness, sometimes thread might enter into the starvation, which means they will be keep on waiting for the lock or a resource. Fifth is no read or a write separation. In a real world example, we basically separate the read or write operation. We allow multiple threads to do the read operations, whereas we restrict one thread to do the write operation. To give a real world example, in a book my show application, we can see that multiple users can basically come and they can see what all the seats are available. Okay, whereas once the user tries to book any particular seat, there will be a lock on that seat. Let's say there is a lock of 5 minutes. Only once that 5 minutes is expired, then only other user can be able to book that seat if it is not booked by the previous user. So this is how we used to basically separate the read or write operation, but this can't be done using the synchronization. In this example we can see that there is a read method and a write method and both are synchronized. So we can't make that this read method can be accessed by the more than one thread at the same time, because synchronized basically allows only one thread at a time. So because of which we will hit with performance issues. So these are the main drawbacks or a limitation of the synchronization. So there is no timeout, no tryLock, and we can't interrupt a waiting thread. There is no fairness, and there is no separation of read or a write operation. Now let's see why these disadvantages or limitations exist at the first place. The main reason is synchronization acts on the monitor lock. This monitor lock is managed by the JVM. So because of which at the code level there is no granular level control how to acquire the lock, how to release the lock, and whether to wait for this duration. That kind of capabilities are not present in the synchronization. To overcome these limitations, in Java 1.5 lock framework has been introduced. So in a lock framework, basically they introduced these methods where they have provided granular level control to the programmer. So to acquire the lock, we have to call this method explicitly. So on calling this one, in case lock is available, lock will be acquired by the thread. In case lock is not available, thread will move to blocking state. On calling the unlock, so we can release the lock on the object that will be acquired by the lock method previously. tryLock will check whether the lock is available on a particular resource. In case lock is available, it will acquire the lock and this method will return a true. In case lock is not available, this method will return false. Then tryLock long time unit. So this is the overloaded method of a tryLock. Here we specify the time. So thread will wait for the specified duration. After waiting for this time, so in case lock is available, it will acquire the lock and this method will return a true. In case even after waiting for this duration, in case lock is not available, this method will return false. Next is lock interruptibly. Let's say thread 1 calls this method and acquired a lock. Now thread 2 comes and it also trying to acquire the lock by calling this method. But thread 1 is taking too much of a time to release the lock. Then we decided to interrupt the thread 2 by calling the interrupt method. So on calling the interrupt method, now thread 2 no longer waits for the objects lock, it will be stopped. That capability is provided by this method. The last one is a new condition. On creating the instance of the new condition, we can in turn call the await and signal. These are being used for inter-thread communication, just like wait and notify methods. So hope these are clear how these are basically used to solve the limitations of the synchronization. So we'll be covering all these methods in detail in the upcoming videos. Now let's see the hierarchy of the lock interface. So this lock interface is introduced in Java 1.5 and it is present in a java.util.concurrent.locks package. Since it is a interface, implementation to this interface is provided by reinterrupt lock class and a reinterrupt read write lock class. So in the next video we will be looking into this reinterrupt lock and a reinterrupt read write lock, how these classes are being used and how to use these methods to overcome the drawbacks of the synchronization in detail. So that's it for the today's video. In the next video we will be looking into the code example and how these are being used. If you found this video helpful, please like, share and subscribe to the channel. Thanks for watching. See you in the next video.